Chapter 4, Introduction to Differential Equation. Here we are given a derivative and we want to find the function whose derivative is given. A differential equation is an equation involving an unknown function y equal f of x and one or more of its derivative. A solution to a differential equation is a function y equal f of x that satisfies the differential equation when f and its derivative are substituted into the equation. The order of a differential equation is the highest order of any derivative of the unknown function that appear in the equation. So here, for example, we want to verify if the given solution is indeed the solution to the differential equation. Verify that y equal 2e to the 3x minus 2x minus 2 is a solution to the differential equation y prime minus 3y equals 6x plus 4. So what we would do here is we will verify that this equation 1 is the solution to this equation 2. In the equation 2, we have y prime minus 3y equals 6x plus 4. So first of all, first thing we need to do is to calculate what is y prime. So y prime is equal to 6 times e to the 3x minus 2. And we mark this equation 3. We substitute this equation 3 into the equation 2. To the left-hand side of equation 2, we get y prime, that is 6 times e to the 3x minus 2 minus 3 times y equal 2e to the 3x minus 2x minus 2. This equal to 6e to the 3x minus 2 minus 6e to the 3x plus 6x plus 6. Simplify, we get 6x plus 4. So this is the right hand side of the equation 2. Therefore, the equation 1 is a solution to the differential equation two. Okay, let's take a look at B. Given y equal pi times e to the negative cosine x, is it the solution to the differential equation y equal y times sine of x? Well, y prime is equal pi times sine of x times e to the negative cosine x. Okay, so this really equal to sine of x times pi e to the negative cosine x equals sine of x times y. That satisfies the given differential equation. Therefore, y equal pi e to the negative cosine x is a solution to the differential equation y prime equal y times sine of x. Identify the order of the differential equation. Like we said earlier, the order of the differential equation is the highest derivative. So here we have the differential equation of order 5. And here we have fourth order of differential equation. Okay. So earlier when I talked about when we verify solution, I said to verify this is a solution of the differential equation. Why is that? It is because when we take if you remember when you do the definite integral, we have a constant, so that's a plus c. Derivative of a constant equal to 0. So if I'm looking at the first problem, in this first problem, whether I have this constant -2 here or not doesn't really matter, right? Okay, so if I just put this constant here, I can have pretty much anything else. Okay, so in that case, you're looking at the constant is given as a number, so that is a particular solution. But if I change that to a c, where c is a constant, it still does not affect it still not change the fact that 1 is the solution to the differential equation 2. It just now I have a general solution. So take a look at the definition of general solution and particular solution. Consider the differential equation y prime equal 2x. Then if you integrate both sides, y equal to x squared plus c, where c is a constant, it is a solution to the differential equation. The equation y equal x squared plus c represent a family of function, so it is a general solution to the given equation. So if now I just say let y equal x squared minus 3, then y equal x squared minus 3 is a member of the family of this solution. So it is a particular solution because we have a constant c. What is that constant? That constant being named as -3. So that is a particular solution. A particular solution can often be uniquely identified if we are given additional information about the problem. Okay. Find a particular solution to the differential equation y prime that passes through the given point and given a general solution. Well, we have y prime is equal to 3x squared y passed through the point 0, 12, and the general solution is y equals c times e to the x to the third. Okay, so the general solution y equal that. This meant that I can start saying, okay, if y equals c times e to the x to the third passing through the point 0, 12, this meant I can rewrite this. I can first solve for c. 12 is equal to c times e to the 0 to the third. This implies c equal 12. Which means the particular solution is y equal 12 e to the x to the third. Let's verify that is indeed the case. So then y prime is really equal 12 times 3x squared times e to the x to the third. So this equal to 3x squared times 12 e to the x to the third. So you can see that this is 3x squared times y. So then the particular solution is y equal 12 times e to the x to the third. Okay. Y prime equal 1 minus x squared. Y prime times 1 minus x squared equal 1 plus y pass through 0, -2 with the general solution y equals c times square root of x plus 1 over square root of 1 minus x minus 1. Since it passed through the point -2, 0, so we have -2 equals c times square root of 0 plus 1 divided by square root of 1 minus 0 minus 1. This means c is equal 1. So then the particular solution is y equal -1 times square root of x plus 1 divided by square root of 1 minus x minus 1. You can verify that this is indeed the particular solution by taking derivative of this equation and plug it into the given differential equation. Let's talk about the initial value problem. To verify that y equal e to the 2t plus 4 psi t is the solution to the initial value problem, given that y prime minus 2y equal 4 cosine t minus 8 psi t, and that y naught is equal to 3. So first of all, let's go ahead and take a look at what is y prime. Well, then y prime is equal to sit e to the 2t plus 4 cosine t. Let's go ahead and plug that into the initial value, into the differential equation. Y prime, that be sit e to the 2t plus 4 cosine t minus 2 times y. That is 2 times 3e to the 2t plus 4 sine t. Simplify, this equal to 4 cosine t minus 8 sine t. And we'll mark this equation 1. Well, we told that the initial value here, that's y naught, y of 0 equal 3. So let's check. Well, y of 0 is equal to 3 times e to the 2 times 0 plus 4 sine of 0. This equal to 3. So indeed, y equal 3e to the 3t to the 2t plus 4 sine t is a solution to the initial problem. Let's say you are given the differential equation. We want to solve the initial value problem. So you're given the equation and you want to solve for y, basically here in this case. Okay, so y prime equal x squared minus 4x plus 3 plus sit e to the x. And we're told that y of 0 equal 8. So y is equal to the integral of y prime. Okay, and in this case it's with respect to x. This is a function of x. So we get 1/3 x to the third minus 2x squared plus 3x plus sit e to the x plus c, where c is a constant. Now we were told that y naught equal 8. This meant that 8 is equal to 1/3 times 0 to the third minus 2 times 0 squared plus 3 times 0 plus 6 times e to the 0 plus c. So then a equals 6 plus c. So C equal 2. So then the solution, to the initial problem is y equal 1/3 x squared minus 2x squared plus 1/3 x cubed minus 2x squared plus 3x plus 6e to the x plus 2. Suppose that a rock falls from rest from a height of 100 meters and the only force acting on it is gravity. Find an equation for the velocity v of t as a function of time measured in meter per second. So what do we know? A rock falls from rest. This means at time t equal to 0, the velocity v0 is equal to 0. Okay. And where's this rock? It is 100 meters from 100 meter high. Which means at t equal to 0, the position of the rock is 100 meters. The only force acting on it is the gravity. Only force acting on it is gravity. Gravity is G. So gravity, G, is equal to negative 9.8 meter per second squared. And this is the gravity, 9.8 meter per second squared. Okay, so find the equation for the velocity v of t as a function of time. So because the only gravity acting on the rock, the acceleration of the rock is the gravity pulling on it. So it's falling down. So negative 9.8 meter per second squared. The velocity is the integral of a of t with respect to t. This means the velocity function is negative 9.8 t plus c, where c is the initial velocity. So we were told that v of 0 equal to 0. This implies negative 9.8 times 0 plus c equal to 0. So c equal to 0. So then the velocity of the rock is negative 9.8 t. Yeah? And this is in meter per second. Because the only force acting on the rock, that is the gravity. Let's say we add a little more into this function. Let's say we want to find the position of this rock at any given time t. The position function, the velocity is derivative of position. So the position is the integral of v of t dt. So negative 9.8 times 1/2 t squared plus c. So we have negative 4.9 t squared plus c. And like we said, the rock starting from 100 meter high would mean the initial position is 100. So s of 0 equal 100 implies c equal to 100. So the position function is s of t equal negative 4.9 t squared plus 100. A car on a freeway accelerates according to the function a of t equal to 15 cosine pi t, where t is measured in hour. Set up and solve the differential equation to determine the velocity of the car if it has the initial speed of 50 miles per hour. After 40 miles of driving, what is the driver velocity? Okay, so v of t is the integral of acceleration. And this is 15 over pi times sine of pi t plus c. And we were told that v of 0 equals 50. This meant 15 pi over pi times sine of pi times 0 plus c equals 50. Sine of 0 equal to 0, so c equal to 50. So the velocity function is equal to 15 over pi times sine of pi t plus 50. So after 40 minutes of driving, what is the driver velocity? So note that here we have t measured in hour, but the question here is 40 minutes, so we have to change it to match the unit. So 40 minutes equal 40 out of 60 equal what? 2/3 of an hour. So the velocity at 40 minutes or at 2/3 of an hour is equal to 15 over pi times sine of 2 pi over 3 plus 50. And the calculator will tell us this is 54.13 miles per hour.